You sitting there, retracing every line and absorbing every word you think is important, convinced that if you just walk through the material one more time, the facts will finally click and lock into your memory. But here's the cold, hard truth. Your brain isn't a hard drive, it's a filter. It is biologically designed to forget almost everything you see. If you just input data without a strategy, you're trying to fill a sieve with water. You feel productive in the moment, but when the exam starts, the sieve is bone dry, and that is epic sad. Stick around, because we're moving past the basics. We're going to dive into the high-level neuroscientific architecture that the world's most elite learners use to hard-code information into their long-term consciousness. This is no joke. By the end of this video, you won't just be studying, you'll be re-engineering how your brain handles reality. To start that re-engineering, we have to look at how you actually store information, which brings us to schema building. Imagine you are happily holding a giant 1,000-piece jigsaw puzzle that you are super excited about. Now imagine you try to look at all the pieces and try to memorize their shapes before even starting to solve the puzzle. That is probably not efficient, right? The knowledge you need for the semester is the giant 1,000-piece jigsaw puzzle. Most students try to memorize the shape of every individual piece. That's a nightmare. The pros don't look at pieces, they look at the schema. A schema is a mental framework, a blueprint that tells your brain where a new fact fits. Neuroscience shows that your prefrontal cortex struggles to hold homeless facts. If a fact doesn't have a house to live in, your brain deletes it during the next sleep cycle. So your knowledge needs to find itself a home as soon as you learn it. For example, you memorize a formula, but as soon as the exam question is phrased differently, you have no idea what to do. It's because you learned the string of numbers, not the logic behind them. You don't need a better memory. All you need is organized folders in your brain. Once you build a strong schema, new information literally sticks to it automatically. Before you dive into a new chapter, spend 5 minutes looking at the big picture. For example, don't just memorize that blood carries oxygen. Ask yourself, does a human and a giraffe have the same heart? If so, how does the same pressure keep a giraffe's brain fueled while it's standing 6 feet above its chest? Fun fact, giraffe heart is bigger and stronger for this exact reason. Did you notice how blood carries oxygen is now embedded in your memory because you thought of the giraffe analogy? At the end of every chapter, look at the headings, the summary, and the graphs. Build the border of the puzzle first so the inner pieces have a place to snap into. But if you don't build the schema, remembering becomes way more difficult. Think of it like trying to build a Lego set without the box art. Sure, you can do it, but you're going to end up with a very expensive plastic pile of confusion. The best way to ensure that confusion never happens is to stop relying on a single way of learning and start using the double-thread secret, dual coding. Around 30% of you watching this right now will remember the metaphors I use better than the actual terms. Why? Because of the dual coding. Your brain has 2 distinct channels for processing information, one for verbal, words, and one for visual, images. When you only read text, you're using 50% of your power. But when you link a word to a specific, simple drawing or a vivid object, your brain creates 2 separate memory traces for the same fact. It's like tying a boat to a dock with 2 ropes instead of 1. If one rope snaps, the other keeps the boat from drifting away. By the way, if you're enjoying these brain hacks, do me a favor and hit that thumbs up. It helps the algorithm realize this video is more useful than cats versus cucumbers. Now, back to your gray matter. Think of your brain like an elite athlete. If a basketball player only practices free throws for 5 hours and do not focus on other aspects of the game, they'll fail the moment the game gets chaotic. To prevent that, you need the brain's version of cross-training, interleaving. Most people block study. They do 50 calculus problems, then 50 algebra. It feels smooth, but it's a hidden trap. It's like a basketball player practicing 100 free throws in a row. They get good at the repetition, but they aren't learning how to ace the game. In a real exam, the questions are randomized. You need interleaving. This means mixing up different types of problems or topics in one session. Interleaving forces your brain to constantly reload the rules for each topic. It feels much harder and more frustrating, But that's because you're actually learning how to identify which tool to use, not just how to use the tool. Don't do 20 problems of type A. Do 2 of A, 2 of B, and 2 of C. It will feel like a mess, but your brain will become an elite athlete. But to actually cross that finish line and make those skills permanent, you need to lean into the struggle that interleaving creates, because that tension is exactly what sets the stage for the aha, neurochemical reward. Have you ever struggled with a riddle for 10 minutes and then, bam, the answer hits you? That rush of satisfaction is a dopamine spike. Neuroscience shows that memories formed during an aha moment are significantly stronger than those formed during passive reading. This is why you should never look at the answer key too early. If you get stuck and immediately check the solution, you just robbed your brain of the dopamine anchor. You made the memory weaker. Struggle for at least 2 more minutes than you want to. That tension is what makes the final click permanent. I'll be honest, leaning into that struggle is exhausting. I tried interleaving my breakfast once, pancakes with egg whites, ketchup, and a scoop of mac and cheese all in one bite. My stomach filed a formal protest, but hey, my neurons were having a party. And that's the thing about your neurons. They aren't just paying attention to the what, they're obsessed with the where. This leads us to state-dependent memory. Your brain doesn't just record the facts, it records the environment. This is called state-dependent memory. If you study in a silent room while sipping coffee, your brain weaves the smell of coffee and the silence into the information. If you then take the test in a cold, stressful hall with no coffee, your brain has to work harder to find the file. You want your study state to match your testing state as much as humanly possible. Mimic the conditions. Try to create a similar temperature, wear similar clothes, same perfume. Only have coffee if you are allowed coffee in the exam hall. It sounds weird, but you're giving your brain breadcrumbs to find the data. Once your external environment is set to your satisfaction, it's time to focus on something more powerful. Change how you navigate your internal one using the method of Loci. Your ancestors didn't need to remember calculus, but they did need to remember the layout of their environment to survive. Because of this, our brains are evolved to be incredible at spatial memory. You can hijack this evolution using the method of Loci for concepts that are particularly hardest to remember. Instead of list of words, you mentally place information along a familiar route, like your walk from the front door to your bedroom. To remember the process of breathing, imagine walking through your front door and seeing a giant neon blue oxygen atom sitting on your sofa, then moving to the kitchen to find a carbon dioxide molecule waving at you while frying bacon. Because your brain is hardwired for spatial navigation, you aren't just memorizing a list, you're simply visiting these strangers in a house you already know by heart. When you're in the exam, you don't remember the fact, you simply walk through your house in your mind and pick up the items you left there. This is crazy, but it really works. Your brain won't let go of a giant singing oxygen molecule sitting on your kitchen table for a very, very long time. We've moved into the deep end today. We learned how to build schemas to give facts a home, the power of dual coding to double your memory traces, and why interleaving is the ultimate cross-training for your neurons. We explored the dopamine anchor, your aha moment, and how to use state-dependent memory and your brain's natural spatial hardware to store data in a mind palace. By applying these advanced layers, you aren't just a student anymore. You're a mental architect. You're building a structure that won't just hold up for the exam, but will stay standing for years to come. Today's small win. So today's small win is, take the most difficult concept you're facing right now and create a dual code for it. Draw one simple doodle that represents the core idea. Label it with one keyword, preferably doodle with black ink and keyword with red. You've just doubled the chances of that information being there when you need it. If this gave you clarity today, let me know in the comments. I go through each comment and it helps me create more videos that can benefit you. If you watch me, you'll feel calmer, clearer, and more in control. Like and subscribe for more tools to help your brain work with you, not against you. Don't miss my next video, carefully crafted to dive deeper into these and many more concepts. It'll take your results to the next level in no time. Thanks for watching.